Which space object would I want to see with my own eyes? Can you meaningfully contribute to science without an astronomy degree? Has dark matter always been around? And in Q&A Plus, my strange relationship with Venus the planet. All in this question show. It's time for the question show. Your questions, my answers, as always, wherever you are across my channel. If a question pops in your brain, just write it down, I'll gather them up, and I will answer them here. All right, let's get into the questions. Dream Shizo. If you had a magic mirror that you can use to see any object in space, what's the first thing you would look for? I would like to see a black hole. You've seen simulations of what black holes look like. Think about the movie Interstellar, and obviously, we see artist illustrations of black holes with all of the press releases and the videos that are released by NASA. But it would be really cool to see one for real. So I think that would be the first thing that I would want to see. Now, if I had the ability to target, like I would want to check out the surface of TRAPPIST-1 just to find out if there's an atmosphere there, if there's life on the surface. That would be very cool. But it's like we don't know enough targets yet. I would like to see what it would look like to be at the center of the Milky Way, where the stars are much more densely packed together. I would like to see what it would look like if you were in the middle of, say, the Omega Cluster, which is the biggest globular cluster in the Milky Way, where you've got millions of stars, they're packed close together. The sky would look bizarre. It would be amazing. I should simulate that. I'm going to do that. I'm going to simulate what it would look like to be inside a globular cluster. Yeah, that'd be really cool. All right, stay tuned for that. Half a bean. Has dark matter always been around? When the universe expanded in the Big Bang, was it dark matter that filled the gaps? What was the universe expanding into? You're kind of asking two questions. And the second question I'm going to tackle first, which is, what is the universe expanding into? Because this is a classic question that we always get, right? Where we kind of imagine the universe as this sphere that is expanding, and that if there's a sphere that is expanding, then it must be expanding into something, right? Like if you go right out to the very edge of the expanding universe, then what is outside of that? It's a perfectly reasonable question to ask. And yet, it is a question that cannot be answered because we have to consider the possibilities for the universe. The first possibility is that the universe is infinite, that it has always been infinite. Even before it began this expansion process, it was infinite, and it is now still infinite. So what does it mean to have a thing that is infinite, that is expanding? It can't expand into anything because there is more universe. But the other thing, and this kind of really gets at the heart of why you have to change your thinking about what it means for the universe to expand. And we kind of have to think about this three-dimensional grid of the universe. Sort of imagine you've got this, grid of squares that goes off in all directions. And over time, all of the cubes in this grid are all getting bigger. It's not like it's an explosion where you've got this one spot and then it's just sort of expanding like this sphere. It is this grid, and that the grid, which might go on forever, is just having, every square in that grid is just getting bigger and bigger. But the other possibility is that the universe is finite. And that's very strange, right? But that the universe was finite at the beginning of the universe, and that the universe is finite now. It's just that the space in between things in the universe has become less dense, and that the universe wraps. So if you go in one direction, you may return back to your starting location because, the universe is wraps in on itself. And so, was dark matter always around? It seems to be that whatever dark matter is, it was present early on in the universe. The kinds of forces that were required to concentrate a galaxy, the kinds of densities that we see in the cosmic microwave background radiation indicate the amount of dark matter that would have to be present for it, for the modern theories of cosmology to hold. And so whatever dark matter is, it was there right at the beginning and is still there now, but space has been opening up, and that has been sort of, if you've got some big old blob of dark matter and then the space is opening up, then the dark matter gets kind of split into two blobs that are now separate from each other and they're expanding. So yeah, dark matter was always there. Air thumbs. When will the expanding universe affect us locally? Probably never. So we are in this expanding universe, and we have been part of this expanding universe for 13.8 billion years. And the scale at which the expansion of the universe has an effect on us is about 3 million light years away, maybe 3 to 5 million light years away. So when you think about galaxies, we've got Andromeda, we've got M33, we've got a couple of hundred dwarf galaxies that are all within 3 million light years of us. And then there's a few things that are kind of right on the edge that maybe are going to fall into our gravity well, or may get carried away by the expansion of the universe. And then everything else outside of that is going to be carried away from us. So every galaxy that astronomers see, except for Andromeda, M33, and a few dwarf galaxies, are all moving away from us at varying speeds. The farther it is away from us, the faster it's moving away from us. And you sort of think about that expansion, and so like part of your mind goes, yeah, but is it like eventually going to tear us apart, tear the galaxy apart, and no, because the actual expansion rate is only sort of experienced at these largest scales, not the atoms holding your body together, the gravity holding the planet together, the gravity that locks the planets to the sun, the gravity that sits within the halo of dark matter that holds the Milky Way together is much stronger than this sort of momentum from the expansion of the universe. And so even if there is dark energy, which is accelerating the expansion of the universe, it will not sort of, change the strength at a smaller level. So it's the kind of thing you would experience. Yeah, if you were 5 million light years apart, then dark energy is going to be sort of balancing the gravity that's trying to pull those galaxies together. But at 10 million now, dark energy is starting to overwhelm and push those things apart. Now, there's one caveat. And, those of you who know a lot about this topic probably know what I'm going to say, which is that there is one idea that if dark energy, which is this accelerating expansion of the universe, is not a constant force, but is in fact a force that is growing over time, then theoretically you could get a situation where suddenly the Milky Way and Andromeda are pulled away from each other, and then the Milky Way is pulled apart, and then the solar system is pulled apart, and then planets are pulled apart, and then you're pulled apart, and then black holes are pulled apart. And that's this idea of the Big Rip. And the good news is that the sort of the modern thinking about dark energy, all of the measurements that have come out in the last probably year or so, this is all very fresh, is that dark energy is either constant or decreasing over time. And so it's the exact opposite, which is that, we're not seeing this potential Big Rip outcome. Instead, it could very well be that dark energy goes away over time. We don't really know yet. This is all still like cutting edge. It's time to shout out all the new $5 patrons and above. Kate Hoople, George Molnar, Thundy UK, Tim Nelson, Aaron Ortloff, Homer Thomas Hodge, Jant, Lecklighter, and Hiram Critchlow. Join the club at patreon.com/universe today. Soren Danciu. Hey Fraser, do you have advice for folks who love astronomy but don't have a degree in astrophysics but want to work in the field? So it really all depends on what you mean by want to work in the field. So if you don't have a degree in astronomy or astrophysics, what do you want to do? Like, do you want to research astronomy and astrophysics? There's really no way to do that in an official capacity without going and getting your degree in astronomy or astrophysics, like whichever the field you want to do. Now, if you already have a scientific training, say you have a bachelor's degree in physics or even something else, biology, whatever, then you can take a master's degree in astronomy and you can take a PhD in astrophysics and you can make that transition over to doing that. But if you're like, you've already got your career and you always wanted to be an astronomer, but you didn't ever get a chance to do it, and now you're like, oh, I really wish I could go and work in astrophysics. So there are related careers like computer science, electronics, physics, where you can work on telescopes, on instrument design. You'll want to take some additional training so that you can understand the underlying principles that the astronomers are searching for. But in general, they have a need of people who are really good instrument designers, things like that. So if you're in a kind of related field, you can make that transition over. And I think about, I have a friend who was a computer programmer and always wanted to work for NASA, and did a bunch of simulations, graphic simulations for NASA, and eventually made his way over and now is working on a NASA mission, but also is producing a ton of really cool visualizations for NASA. So you can kind of make that transition. But if you want to just participate in space and astronomy research, there's a lot of projects that just regular citizen scientists can work on. Astronomy is one of the fields that relies on collaborations with amateurs and citizens more than almost any other field. Maybe bird watching is more, but apart from that, amateurs are discovering comets and asteroids, and they are observing on variable stars, and they are discovering exoplanets. They are working for projects like Galaxy Zoo or CosmoQuest, where you're working with large numbers of people and you're evaluating surface features on the moon to count craters, and you're participating to a research project that is then someone is actually doing research on that. So there are a lot of projects you can get involved in as an amateur. And then if you just want to learn and kind of just like wish you had the training in astronomy, just get a textbook and go through the textbook. Angela Collier had a great video about a year ago where she said, like, if you want to understand physics, just get a physics book, start at the beginning and read the textbook and do the problems. And when you get to the end of that textbook, just like Physics 101, the kind of thing that you would get when you go to university, or an astronomy textbook, that you will understand more about this field, about astronomy, about physics, whatever, than almost everybody. And you will be able to understand the stuff, the research that's being done, the things that I'm talking about at this really high level. And so a lot of stuff is very accessible. So I think, you've got to be realistic about where you are in your current career. There's not a lot of jobs in astronomy, right? They're very difficult to get positions in as researchers or as professors or people working in observatories or people at NASA and so on. Not a lot of jobs. So you got to want it really badly and be willing to really suffer and sacrifice to get your degree, to take a shot at getting one of those careers. But I don't think you need to have the official degree or even the official job to participate in astronomy. There's so many projects you can get involved in. So, we should really put some resources together to give people some ideas on how they can do that. Because, I interview people who are working on citizen science projects. Obviously, my Astronomy Cast co-host, Dr. Pamela Gay, she runs CosmoQuest, which is organizing citizen scientists. So there are a lot of projects that you can get involved in. It's just a matter of seeking them out. Zeldemort, Galactic Defender. TRAPPIST-1 star likely strips the atmospheres in the alien hunt. Are we focusing on it because we're lacking options? What are the Earth-like worlds orbiting calm sun-like stars that we should be obsessed with instead? So the problem is that the current crop of telescopes are not able to resolve Earth-sized worlds orbiting around sun-like stars. Now, we could theoretically detect them with the transit method if we knew where to look, but so far, none have been identified. And the problem is that you have to consider the times involved. So when NASA launched the Kepler mission, like a decade ago, more than a decade ago, this was the telescope that was going to find another Earth because it was going to stare at the same spot in the sky for years on end. And you think about what it takes. We're discovering a lot of these red dwarf stars with planets orbiting around them because the planets only take a few weeks or maybe, a couple of months at the most to go around the star. But for a star like the sun and a planet like the Earth, then you're going to need to wait a year to see one transit of the planet in front of the star. And then you'll have to wait another 365 days for another transit. And then you'll probably need to wait another 365 days for a confirmation. So at the bare minimum, you're looking at 3 years of observation in one small part of the sky to get that discovery of an Earth-sized world orbiting around a sun-like star. And unfortunately, the Kepler mission died. And it wasn't able to look long enough. Now, it might have seen some of those transit, but it only would have caught one.
And then you don't know, was that transit one that happened very quickly or one that takes a year? It takes 2 years to go in front of the star. And then the only telescope that's been put in operation that has similar capabilities is the TESS mission. But the TESS mission is a $200 million mission compared to the Kepler mission, which was a multi-billion dollar. Like Kepler was a flagship. TESS is a very small spacecraft. Right now, with the best telescopes that we have and the kind of cadence that they're capable of detecting, we only know about the Earth-sized worlds orbiting around red dwarf stars. And we only have the capability to study the atmospheres of those worlds. So James Webb, the Hubble Space Telescope, the Extremely Large Telescope, ALMA Array, the Gemini North and South, like all these telescopes are enormous and capable, but they don't have a coronagraph that's capable of blocking the light from a sun-like star to resolve. The difference in brightness is just so ridiculous. Essentially, the star is 10 billion times brighter than the planet. While in the case of red dwarfs, it's, a fraction of that difference in brightness. And so the coronagraphs on board James Webb, for example, are able to block the light from the star and reveal the effect of the planets around them. The TRAPPIST-1 system is this bizarre fluke. This system is only about 40 light years away from the Earth. And that is relatively close compared to, the distances that exoplanets have been found. Like we're finding exoplanets out into the hundreds of light years away, even thousands of light years away. But the TRAPPIST-1 system is only 40 light years away. So it is relatively close. And there are 7 Earth-sized worlds orbiting around the star. And it's lined up perfectly so that we can watch these planets transit in front of the star. And so there are no other star systems that we know of today that hold a candle to the sort of quality of the science that can be done with the TRAPPIST-1 system. And so it is still like number one with a bullet of the priority for scientists to study. And when new telescopes come online, they're all going to cut their teeth on the TRAPPIST-1 system. It is just that good. Now, if we get a new generation of big telescopes, things like the Habitable Worlds Observatory or the Large Interferometer for Exoplanets, the LIFE telescope, then you're going to get a new capacity to not only observe exoplanets, but even to detect them, to even know that they're there. Because, when you think about the volume of space, even within 10 light years of us, there's probably 100 stars. Within 100 light years, there's probably 50,000 stars, right? Like there's a lot of stars in our area. And so only a fraction of them have been studied and really carefully observed for exoplanets. And we happen to find them when they line up perfectly, which is less than 1% of the star system. So we just need much better tools to be able to find them. Did you know you can watch the same video with no ads and get a bonus question over on Patreon completely for free? We call it Q&A Plus. And this week's bonus question, how do I feel about Venus? It's complicated. I'll put a link in the show notes. All right, those are all the questions that we had this episode. Thank you, everyone who put your questions into the YouTube comments, everybody who joined me for the live show. I'm going to talk about my history with Star Trek. But first, I'd like to thank our patrons. Thanks to Abe Kingston, Barely Griffin, Brian Bodie, Caradron, Chuck Hawkins, Commander Bill, Xine Nelson, Darkfinger, David Gilson, David Matz, Evan Pro, Greg Feely, James Clark, Jeremy Madden, Jim Burke, Jordan Young, Josh Schultz, Marcel Switz, Michael Purcell, Nordspace, OneStepForAnimals.org, Paul Buck, Rank Haidu, Richard Williams, Sean Sargent, Stephen Fallon-Munley, Team 49, Telescopes Canada, Wolfgang Klutz, and Zeldabor Galactic Defender, who support us at the Master of the Universe level. And all our patrons, all your support means the universe to us. So I gave a list of my top 10 science fiction shows recently, and maybe I'll put a new version of the list down into the show notes below. And on that list was Star Trek: The Next Generation. And I put it there not because I consider it to be one of the best science fiction shows ever made. I'm not sure if it is on my list anymore, but I had to put something because Star Trek has been so influential in my sort of science fiction journey. I was really lucky when I grew up. My parents were giant sci-fi nerds, and so we would have Star Trek on in our house whenever it was on. I was born in 1971. I was probably sort of cognizant of Star Trek by the time I was like 6 or 7 or so. And, we were already into rerun season at that point. And so the old show was on, and both my parents really loved Star Trek. And so we would watch them. 1978,
7, we went and saw the first Star Trek movie, and I didn't really understand what was going on. Star Trek II, The Wrath of Khan, freaked me out. It was so scary when they put the little bug in the guy's ear, but the rest of the movie was just absolutely fantastic, and I really enjoyed it. My parents foolishly bought me a phaser, which made a horrible sound, and the thing went missing a lot, and yet I would find it in closets hidden, which was very strange because I don't remember putting it there. Everything changed when I was sort of at the end of high school when Star Trek The Next Generation came back on. And there was this show that sort of was kind of like the old show, but then had a lot of additional interesting new characters, new ideas, and new special effects. And I absolutely loved the show and would just watch that. And it became this sort of constant companion. And Star Trek The Next Generation was going, and then they came out with Deep Space Nine, and they also had Voyager. And for a while there was just so much Star Trek that was on. And I was in like sci-fi heaven. Now, other shows have come along that I consider to be better. Like, I think The Expanse is the best science fiction television show that's ever been made. And we added 2 new ones to my list this year with Pluribus and with Alien Earth. But still, Star Trek has a special place in my heart as this sort of both an exploration into science fiction topics, many of which overlap with the kinds of science fiction that I really like to read, but it had a hopeful vision of the future, one where we can all get along, that there are greater ideals that humanity can strive for as we explore the cosmos. And it is not this cynical view about what the future might hold. And as an optimistic person at heart, I really enjoyed that and still love the ethos of Star Trek and watch as they implement this. Now, this is coming at a time when the new Starfleet Academy has come out, and I'm sure you want to know, what do I think about it? So the first episode I thought was terrific. I really enjoyed it. Good action. The sets were a little weird and glossy, but still, I kind of enjoyed how it all broke down, and I was sort of nervous that it was going to be CW, but for Star Trek, but it kind of was a little bit, but not so bad. The second episode I found really disappointing. It really was CW for Star Trek. And if it continues on that vein, I probably won't continue watching it. Hopefully it will have more hooks and teeth and not just be this sort of teen drama, but we will see. But yeah, Star Trek, we're closing in on whatever it is, 1,000 episodes of Star Trek across all of the shows that they've done so far. What an amazing piece of science fiction legacy that we have with us in this modern time. And so if you haven't watched Star Trek, start at the beginning and follow along. It still holds up. All right, we'll see you next time.